In this video, we're going to be looking at some of the examples in Lesson 21-2 in your Springboard. We started this in class. We're going to pick up here on page 285 with question number 2. Now, the examples that we did in class, most of those simplified down to either a constant like 1 or 0, or maybe simplified down to a single trig expression. But that doesn't always happen. These are going to simplify down to something a little less simple than what we've seen previously. But also these two examples that we're going to look at here, they're going to introduce to us some different strategies that we can use to manipulate these identities. Here on number 2, we've got sine squared theta minus cosine squared theta over sine plus cosine. And one strategy that's going to be good for us to use on this one is factoring. If you notice here in the numerator, we have sine squared theta minus cosine squared theta. So what I have there is a difference of squares. I can factor that to be sine theta minus cosine theta and sine theta plus cosine theta. And so that strategy here is factoring. On this problem, they're wanting us to list the strategy out to the side. So sometimes factoring is a good strategy to use. We can see in the next step that sine theta plus cosine theta, those are going to divide out. And so for that step, I'm just going to say simplify. And then we're left with this simplified version, sine theta minus cosine theta. And at that point, there's really nothing else you can do to make that any simpler. Now, if we take a look at number 3, we're going to see several different strategies at use in this one. We have the original expression tangent theta plus 1 over tangent theta. And we could start this one out different ways, but let's look and see what the book did here. My next step says tangent theta times tangent theta over tangent theta plus 1 over tangent theta. So notice what they tried to do here, or what they are doing here, is taking this first expression of tangent theta and turning it into a fraction with a common denominator, multiplying by tangent theta over tangent theta. So in this first step, they're getting a common denominator. And this is going to be a really important strategy for us. Anytime we have two separate expressions or fractions, we're going to need to be able to get a common denominator. Now in the next step, they've just combined the two fractions together, because that's what you can do when you have a common denominator, is go ahead and add them together. And so they ended up with tangent squared plus 1 over tangent theta. They get that this tangent times tangent gives you the tangent squared, and then plus 1. All right, the next step. If we look between these two steps, the difference is that we have secant squared in our numerator. And so what happened there is that an identity was used. If I go back up here to this step, tangent squared theta plus 1, remember we discussed the strategy that when you see squareds and ones, you should check your Pythagorean identities. And if you look at your Pythagorean identities, you'll see that tangent squared theta plus 1 equals secant squared theta. And so at this step, we just substituted using a Pythagorean identity. Pythagorean identity there in that step. Now at the next step, I had secant squared theta over tangent theta. Now we see 1 over cosine squared theta and then sine theta over cosine theta. So what happened in that step is that we substituted, actually I'm going to rewrite it, not as substituting, I deleted off too much, but really change everything, change all to sine and cosine. That's the strategy that was being used there, sine theta and cosine theta. So they changed secant squared theta to 1 over cosine squared theta. They changed tangent theta to sine theta over cosine theta. And that's a good strategy, getting everything in terms of sine and cosine, hopefully so that some things will divide out. Now in the next step, if you notice on the step we were on, right here, we're dividing with two fractions. So in the next step, instead of having it written as division, we're rewriting that division of fractions as multiplication. So rewrite division as multiplication. Multiplying by the reciprocal of what you're dividing by. So sine theta over cosine theta becomes cosine theta over sine theta. Now at this point, I see that I have a cosine theta in the numerator and cosine squared theta in the denominator, and so that means one of those can divide out. I'm going to divide cosine theta and divide out one of the cosine thetas in the denominator, so that I'm left with 1 over sine theta times cosine theta. And in that step, all we did was simplify, divided out what we could. Then in the last step, I had 1 over sine theta times cosine theta. They've changed that to cosecant theta times secant theta. And so this was a rewrite using reciprocal identities. All right, so on the next page, we have these three problems. We're going to practice these in class tomorrow. What I want us to do now is to skip on down and look at examples C and D. I'm going to work these examples out on a blank screen because, of course, Springboard already has them worked out for you, but I'm going to work through it and talk about it. In these two examples, we are verifying an identity. And what that means is that we're starting out with an equation where one trig expression is said to be equal to another trig expression. And what we need to do is prove that that's true. The thing we need to keep in mind here is that because we're trying to prove that it's true, at this point when we start out, we don't really know for sure that these two things are equal. That's a question. And so we can't move things from side to side using our algebraic techniques because those only work for equations. What I want us to do here when we verify identities, I want you to draw in like a wall between the two sides of the equation. And what we're going to do is work on either side that we want until we can transform them into looking the same, until they say that they are the same thing. And then we know that they're equal. So for this example, I think I'm going to start over here on the left side. You can work on either side of the wall that you want, but on the right side I only have cosine theta. There's really not a lot I can do with that. So I'm going to start on the left side, cotangent theta times sine theta, and I think I'm going to use the strategy of changing things to be in terms of sine theta or cosine theta. This cotangent theta, I can rewrite that as, I messed up, as cosine theta over sine theta using that quotient identity. And then sine theta, we're just going to keep that, but I'm going to write it over 1 so that my fractions are lined up. So cosine theta over sine theta times sine theta over 1. I notice that I have sine theta on the top and the bottom, and those can divide out. And when I do that, I am left with cosine theta, which is equal to, it's the same as what I have on the other side. Let's look at another example. Okay, in this example, we have 1 over 1 minus cosine theta plus 1 over 1 plus cosine theta equals 2 cosecant squared theta. And we want to verify that these two things are equal. So I'm going to start out by putting up that wall, and we can work on either side of the identity that we want to work on. I think I'm going to start over on the left, and I notice that I have two fractions that are being added. And on the right side, notice that there's only one term over there. And that's kind of a clue that we need to get a common denominator so that we can combine these two fractions together into one. So to do that, this first fraction, 1 over 1 minus cosine theta, I need to multiply that times 1 plus cosine theta over 1 plus cosine theta. Because my common denominator is going to be 1 minus cosine theta times 1 plus cosine theta. And then my next fraction, which is already 1 over 1 plus cosine theta, I need to multiply times 1 minus cosine theta in the numerator and the denominator. So if we do that, as I add them together, I'm going to go ahead and make my denominator 1 plus cosine theta times 1 minus cosine theta. And then in the numerator, let's see, for my first fraction, I have 1 times 1 plus cosine theta, so that would just be 1 plus cosine theta, plus, and then for my second fraction, 1 minus cosine theta. So now let's see what we can do to simplify here. I have this 1 plus 1, so that would equal 2, and then cosine theta minus cosine theta. So cosine theta minus cosine theta, those just become 0, and so I'm left with 2 in the numerator. Now in the denominator, a good strategy here is going to be to go ahead and multiply this out. We saw previously how factoring can help us. This is an example where multiplying this out can help us. And notice that I have the same terms here, 1 plus cosine theta, 1 minus cosine theta. This is going to multiply out like a difference of squares, and I'm going to be left with 1 minus cosine squared theta. Now at this point, we might want to, let's go ahead and look over here on the right side, and we've got 2 cosecant squared theta. One thing I can do with that is rewrite cosecant in terms of either sine or cosine. And if you remember, cosecant is the reciprocal of sine. So I can rewrite this as 2 times 1 over sine, and it's going to be sine squared theta. Since I have cosecant squared theta, we're going to rewrite that as 1 over sine squared theta. So I'm kind of close here on both sides, but they're not quite the same yet. Let's consider this, and I'm going to kind of take a break from what we're doing here. Let's consider our Pythagorean identity. Remember that sine squared theta plus cosine squared theta is equal to 1. And that's how we learned the identity. Well, here on this side, I just have sine squared theta. If I solve my Pythagorean identity for sine squared theta, I'm going to do that by subtracting cosine squared theta over to the other side. And so we get that sine squared theta is equal to 1 minus cosine squared theta. And so that's another form of the same identity. And so what that means is that I can replace my sine squared theta with 1 minus cosine squared theta. So if I go back to this step right here, and we're going to rewrite that as 2 over, and instead of sine squared theta, I'm going to substitute in 1 minus cosine squared theta. And now both sides are the same. Now I will say that is just one method for verifying this identity. There are definitely other ways that you could get there correctly. And sometimes that's the fun of identities, sometimes that's the frustration of identities. But we're going to practice this more in class.